Hello, Regis students. So recursion, what is that? Kind of a fancy name. Well, it's a way that a function will keep calling itself in a repeated fashion, and that is because it's going to then go and distribute work. And what that means is a very old computing technology going back decades, and it would be able to access different memory streams. So when you are searching for information to go build a report, well, you access different kernels in your GPU to fire off and then help get that work done faster. So think of it as a number of minions running around, or 1 to n, okay, 1 to n executions, and then the work is then being, what's cool is the work can go from left to right, the work can go from right to left, that's called from tail to head. The work can start at different segments, it can use lots of features called stacking to parse the work about. So it's a smaller input until the retrieval case, the information you're going after, is sought and it's distributed across different work streams. So when you get into these large systems of information, programmers have been spending decades making it easier to use and making these type of things faster. But you still need to know what this feature is, so you will know if you need to add it when something gets too complex for you down the road, and you realize that, oh, I shouldn't be using sorting, I need to know what recursion is. So what I tried to do here is I went into some of my old textbooks, because I had really good pictures to help you build a visual image of different recursion methods. And it's not always taught this way now, and I think that's too bad. So let's get in there and take a look. So I'm going to give you 5 panels, and panel's going to be described. And what I want you to do is I want you to read the information. So this is a panel of a rectangular array, but you're going to have a nice picture to be able to then visualize. So if we look at an array of data like you're in a spreadsheet, you're able to see here, well, you go from left to right and then go back around, left to right, left to right. You could have done column ordering. You could go down the column and back to the top, and down the column and back to the top. So in the 7 pillars of Python, that's why it has been out there for you to understand that data goes from left to right, from right to left, top to bottom, bottom to top. And recursion will allow you to start at any point, and you just have different controls for doing that. Now, some of these pages didn't come out that good, so I did apologize. I couldn't get the camera to work quite the way that I wanted. I was a little aggravating, and I'm sorry. But this is a recursion pattern of going down in a tree. And so the P is it distributed 3 ways of starting to do work, and you see that there's feedback going on. But then it was able to go down into this recursion tree where it was getting access to more information. Now, this is getting into multidimensionality, okay? So this picture here, although it is a circle and it's showing you the partition of the data, what you actually need to think about is a hyperplane. And I give an example of that down later. Now, this is a classic example of tail recursion. And what this is that you will, instead of starting this image that you see here is actually a block of data, okay? That's what you need to think of it as, a block. A lot of times you would start going in the memory. I'm going to go down a block, and I'm going to start transversing. And when I'm done with here, I'd go back up. But oh, look, the recursion tree, it was able to generate to go to another level, and then it goes all the way back to the top. Well, you could have started with the data at the tail. And so what it means is that it starts on the right-hand side instead of starting on the left-hand side. And so that's what these images are trying to help you understand. Now, check this out, all right? So when you when we start thinking about these different programs, all right, well, the panel, oh, I'm sorry about that. The images are, this is of a stack, okay, and the stack is, you're going to go grab data, it's going to put data in different stacks, it's going to put things in different chunks, and it's going to keep breaking it all up until it is, over time, finding the data that originally it was executed for. So I hope you really find this cool. It is, the concept of really what's going on in the memory of the chip. And in other classes that I teach, we would get into bits and bytes of how that's done down at a memory allocation level. But you're just at the programming level. So here's a bigger tree, and this is just to show you the concept of, well, recursion will keep generating. Now this is for disks. It needs to go into 3 different disks to go find the data. It's like having 3 different CDs, and it had to then create a routine across each of the 3 CDs, 1, 2, 3, and dive down, and then the data is going back and forth to pull it back up. But the main thing that I want you to walk away with, all right, is when I want you to have the visual of whatever data that you're looking for, okay, that there is a plane in between it, like a hyperplane. And because this is what we do in data science now all the time. So if you needed to find this purple cube, well, cool. Well, first off, it's cool that in an XYZ data, so this would be like a 3-dimensional data space, you're able to isolate this data here. And then recursion helps you build pointers, build parameters, so that you would then be able to go access this quadrant as opposed to other quadrants. So that's my introduction for you. I hope that you're really enjoying all this new learning environment, and thank you so much.